Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2023 Maths Methods exam 2. I just got, my hands on this today. And I'll be honest, I just want to finish this because I have exams tomorrow and I don't even want to do methods tomorrow. So let me just, smash through this paper right now. It is currently 12 a.m, close to actually, 12:16 a.m. So it's quite, we're in the middle of the night and I just want to get this done. Quite tired, but I hope everyone did well in this exam. You tried your hardest and that's all you have to do these times, Okay, guys, like always, before starting the video, guys, if you guys want private tutoring in specialist methods, physics and chemistry, please, you can email me through this email and we can discuss tutoring. So let's smash through this paper. I just want to get this paper done pretty much. Okay, question 1. Let f of x be all reals this, where f of x is that, part of the graph of f is shown. State the coordinates of all axial intercepts of f. Okay, easy. So what I'm going to do is actually go on my CAS and just kind of define f of x. Just make my life. So x minus 2 times x plus 1. Okay, we got this. And we want the... okay, what about... So what's the y-intercept? So it's at 0 and 0. What about if we solve for f of x equals 0 for our x-intercept, and we get -1, well, we already have this one over here, and x equals 2. And so let's write those down. So the first one will be 0, 0. Second one will be -1, 0. Third one will be 2 and 0. Is that right? So 0, 0, -1, and x equal to. Perfect. Find the coordinates of the stationary points of f. Easy. So to do that, I'm just going to take this again and just use this over here. Find f dash of x, and those are your your x coordinates. So what's f of this one over here? Oops. And what's f of this one over here? And we get these two. So let's write those down. So your first coordinate is -√7 minus 1 over 3, 2, 7√7 minus 10 over 27. Alright, and your second one is √7 plus 1 over 3, -2, 7√7 plus 10 all over 27. Is that all? Okay, perfect. So move on to the next question. Let g of x be this. Find the values of x for which f of x and g of x equal. So, okay, let's write g of x is what? So g of x is x minus 2, and we want f of x equals g of x, and we want to solve as I call my x. Here are your values of x. So let's write those down. So x is equal to -√5 plus 1 over 2. X is equal to √5 minus 1 over 2, and x is equal to 2. Write down an expression using definite integrals that gives the area of the regions bounded by f and g. Easy. So let's just graph this to visually look at it. So f of x, g of x. And okay, so we found the point of intersection. So we have the 3, so this one, that one, that one. So to find the area bounded by here and here, well, we can just say right over here. So the integral from this point of intersection to this point of intersection, so from here to here, the top function is f of x. So f of x minus g of x dx. Now, plus the area from this is from here to here, so it's this over here, put it over here, 2 over here, and the top function is your g of x. Let's write g of x minus f of x. Yep, so dx, and let's write this definite integral in our in our paper. So it will be this -√5 plus 1 over 2 √5 minus 1 over 2 f of x minus g of x dx plus √5 minus 1 over 2 to 2 g of x minus f of x dx. So, hence find the total area of the regions bounded. Easy. Let's just enter that. And we get 2 2 decimal places, that's 5.95. So 5.95 units squared. Let h be this, h of x that, okay, where h of x is equal to f of x plus k. So f of x has gone through a translation up or down to get us to h of x, to get this equation, where a and b and k are elements of all reals. Find the possible values of a and b. So, okay. Alright, so h of x, have a look at h of x. So, we know that if I just have a little graph of h of x, let's say this is, a, A, and this is b. We know that there's squared on b, so the factor is squared, so it's going to be reflected, and it's going to go to a. So, the difference between f of x, so f of x, we need this kind of reflection here. So f of x plus k, so have a look, if I go here, and just, let's trace this over here to show you how this looks. So this is f of x plus k, so now we can translate it up or down. So if we want to meet that condition of h of x has to have, so if you go up and down, if we translate it down, we need to translate here. Can you see how this now gets reflected? So this could be b, and now this could be a. So this, also meets the condition. But also we can translate this up. So it was originally like that. We can translate this up. And now we can also get this also meets our condition. Because this could be our b and this could be our a. So we actually have two situations here, which is good. So let's think of how we can do that. So just having a look at this, what do we know? Well, k, for the first one, k, we want to translate k. So k, well, our minimum value, which we've already calculated. So our minimum values are here. So your actual, no. So, okay. So your stationary values we've calculated here. So this one will be this over here. And we want to translate it down this much to get this graph to be like this, to meet our condition. So let's do that. So we can say 4 marks. So how would you get those 4 marks? You would want to say, let's rub that out. We want f of x. Well, let me actually take that out. Let me write it in a different color. So we want f of x minus this value over here, which is 2. Let me just go on my calculator and just find it. Okay, so it's minus 2, 7 root 7 minus 10, all over 27. So this should actually equal to h of x. And we also have the other case where f of x is, if I go over here, where we already have the other stationary point, which is this one over here, which is this over here, and we can translate it up that much units to get this condition over here. So if we go up, we meet this condition. So, all right, that's all right. So let's do that. We also have another condition. Let's make sure I write that. Plus, 2, 7 root 7 plus 10 all over 27 h of x. So these are two conditions. Perfect. And yeah, we can solve them in our calculator. So if I know that f of x is going to be, all right, so f of x is going to be minus this one over here. We'll take this one over here, bring it over here, minus this, and that's going to be our h of x. Now, easily we can just solve answer equals 0, x, and we get these two beautiful values, yes. So, which one's A and B? Well, just let's go up, have a look on top again. So this one's when we translate it down. Oops. So this one's when we translate it down. So the B value, which is the squared value, so your B value is going to be the negative one. So this over here. So yes, so we'll have to write it as, one case for this one is that B is actually negative root 7 minus 1 all over 3. And we also have A is therefore 2 root 7 plus 1 over 3. So these are your two. Oh. Wow, it's very shallow. But yeah, these are your two, these ones. But we also have to write the other case. So let's do the other case too. So we said f of x plus the other one. If we go up here, which is this one over here, we want to plus this, okay, and we want to solve answer equals 0, comma x, and we get this. And our b squared for this one is, remember, if putting this up, it's going to be the positive one, which is x equals root 7 plus 1. So your next one is a equals, oh wait, your b one is root 7 plus 1 over 3, and your a is negative 2 root 7 minus 1 all over 3, if I'm not mistaken. Is that right? So b value, yep, so we translated it up. Okay, yes. That's that, yeah. Perfect. So these are your two solutions, F for A and B for that case. So let me just sketch that like that. Okay, move on to the next question. Question 2, the following diagram represents an observation wheel with its center point P. Okay, this question looks so similar to, I think of, I don't even remember which exam, 2018, 2017. Passengers are seated in the pods, which are carried around as the wheel turns. The wheel moves anti-clockwise with a constant speed and completes one full rotation every 30 minutes. So that's its actual period. When a pod is at its lowest point of the wheel at point A, so at this point, it is 50 meters above the ground. The wheel has a radius of 60. So this is here. The wheel has a radius of 60. Okay. Consider the function h on t, which is this, for some b and c elements of all reals, which models the height above the ground of the pod originally situated at A after time t minutes. Show that b equals pi over 15 and c equals that. Very nice and easy. So, well, okay, what do we know? Well, don't we just know already that, okay, what is this maximum? Well, what's this actual minimum value? This minimum value that's going to occur. Normally, it's going to be c, it's going to be c minus, so it's going to be c minus 60. And that's should equal to 15, which is just your minimum value over here. So you therefore, let's write that down. So c minus 60 equals 15. So c is actually equal to 75. That's the kind of range. So it's this c minus that, or if you want this point of maximum, it's c plus 60. Yeah, we could have done also that. So what about b? Well, b is just a period. So if we know that 2 pi over b is actually equal to the 30 minutes, therefore b is just 2 pi over 30, which is pi on 15. There we go. You've shown that, and that's all you need. Done. Next question. Find the average height of the pod on the wheel as it travels from point A to point B, this point B. Okay, so it's gone through a quarter of a rotation. Give your answer to this. Okay, very easy. Well, we know that full rotation is 30, so half rotation here is 15 minutes. Then to go over here, it is just 7.5 minutes. Is that right? Or we can double check it. So let's just first define the function. So let me just control end this. So h1t is negative 60, cos our b value here is pi times t over 15 plus 75. So we got this, and what we want is what's its height at b. Well, its height is 60 plus 15. So it's h1t. What's 60 plus 15? We're gonna solve answer comma t. Given that t can only be between 0 and 30. And it should be the first t. Yes, it should be this first t, which, yes, it is 7.5. Perfect. So we can say, yes, the average height is just the average value. So 1 over, so from 0 to 7.5. So 1 over 7.5 of the function h on t dt gives us what? So 1 over 7.5 times this integral from 0 to 7.5 h on t dt, and that gives you this value. To correct to 2 decimal places, that is 36.8, so 36.80 meters. Done. Find the average rate of change in meters per minute of the height of the pod as it travels from point A from point B. Easy. So it's just going to be h on, well, what's so we said 7.5 for the first one, so minus h on 0 all over 7.5. That's going to give us h is 7.5 minus h of 0, 7.5. That gives you 8. So we can say 8 meters per min. Done. So after 15 minutes, the wheel stops moving and remains stationary for 5 minutes. After this, it continues moving at double the speed of its previous speed for another 7.5 minutes. The height above the ground of the pod that was initially at point A after t minutes can be modeled by the piecewise function, where k is greater than 0 and m is greater or equal to 0, where n is an element of all reals. Okay. So h on t, okay, makes sense. So after 15 minutes, so from 0 to 15 minutes, the wheel stops moving and remains stationary for 5 minutes. So this 5 minutes, it remains stationary, as we can see that k is constant. So easily it can be found by just what's h of, the value of k can be just found by subbing 15. So what is h of 15 should equal your k value. So your k is what? What's h of 15? 135. 135. Okay. Your value of m, so it tells after this, it continues moving double its previous speed for another 7.5 minutes. So it moves double the speed. Okay, so I want to 100% make sure that's okay. Okay, so let's think about the period. So if we were, so we said 30 minutes was the normal, actual normal rotation speed. So if we wanted to double, it'll be 15 minutes. So let's have a look at, so h on t is this at 30. So if I wanted to do double it, it will be, wait. H on is 30. If I wanted to double it, it would be h on 2t, 2 pi over 2 t, so 2 pi over m, which is 2 pi. And it will half, it will half the 30, which will give us 15. Yeah, so m is equal to 2. Is that right? Wait. I need to think about this. Wait. Or is it half? Slash dilation by a factor of 1 over m. So, think about it. Let's think about it again. So, if we know the period of 2 pi over, let's go up here. The period normally was 2 pi over, pi over 15. Pi over 15, which gave 30. And if we wanted half this, we would half this too. So if I had that, m equals 2, it would be h to say 2t, so it'll be 2 pi over 2, so it will actually half, whereas the other one's just 2 pi over normal. Yeah, so that looks right. I hope that is. So k is equal to 135 and m equals to 2. It's those two. Find all possible values of n. Okay. Now, what do we know? So, we know that after this, it continues moving at double the speed for another 7.5. Double its speed. So, now we know that this over here is 2. So, this is h2t plus n. And now we know that it moves double that speed. We know it moves double the speed at 20. So, yeah. So, if we say h of 2... So, if I say h of 2t plus n should equal to 135. Because if you look at the 20 over here, if you look at the 20, when it starts, doubling speed, at that value, this value over here should actually equal to that value at this time. So yeah, so at t equals 20. So if I take, so t times 20, so here will be 40. So this will be 40. Yeah. Let's use our calculator. So it's a general solution because it says find all possible values. So we can say h of 40 plus n should equal 135. And we want to solve answer comma n. And we get this value of n. So your n is actually just equal to 5n. So 6 n plus 1, where n is an element of all integers. Is that true? Is it an element of all integers? Yes, it is. N is an element. Yeah, you can actually take any values. All right, good. Next question. Sketch the graph of the piecewise function w on the axis shown. Show that the coordinates of the... Okay, this is easy. So let me just go on top and sketch that on my calculator. So we got h on t. Actually, let me just go on here. Piecewise function 3. So h on t. Actually, we need to get it in terms of x. This one over here is 0 root x root 15. K, which we got, was 135. 15 root x root 20. This one over here is just h of 2t or 2x plus okay, plus n. We'll call it n. Let's put a variable n. 20 square root x square root to 27.5. Okay, we got this, and let's put a value of n and just go menu and zoom fit. So let me just kind of zoom out. Okay, we get this. Now, what do we know? Well, we know that n, we said, so if we sub in n equals 0, that's 5. So let's put it at 5. Aha, beautifully. It's continuous and it works. What about if I subbed in n equals 2? So 2, 12, 12 plus 1, so 13 times 5. Oosh. Look how much it is. If I subbed in 1, it's that, then, yeah, if I subbed in 1, so it's 6, wait. So if I subbed in 0, that'll be that. If I subbed in 1, 6 plus 1, 7 times 5, so 35. Does that also work? So it looks the same graph. So, you know, putting all those values still makes it look the same graph. So we can actually sketch it perfectly. So let's go down to the question. And yeah, to make our life easier, what I'm going to do is I'm just going to make sure it looks the same as the paper. So if I go out on my windows, so the minimum is 0, your maximum is at 30, your X scale is gone by ones, your Y scale minimum is 0, here is 180, and your Y scale goes by tens. Perfect. And where we're going to go menu, and what we're going to do is go view, grid, lined. Perfect. So we can just copy this whole thing beautifully into our paper. And yeah, and because it says showing the x coordinate of the endpoints, yes, there are endpoints, by the way, because from that, so there's going to be an endpoint from here to here. Yeah, so first let's actually sketch it. So I just want to trace. So if I go up and just look at the endpoint, so we know that at 0, there's going to be this point. So 0, 15. So let's put that point on our graph. We also know that there's an also endpoint. Oops. At 15. So which is 15, 135. So 15 has to be 135. So 135, 15. Right over here. And we also have, go up, 20. So if we write 20, so it's till 20. So till 20, it's 135. So it's at this point. And what about 27.5? So if I write 27.5, we get 27.5 is 15. So it is right over. So, okay. 25, 26, 27. So 27.5 is right over here. And 15 is right over here. Perfect. So having that, now I can easily draw it. Just looks like this. Be careful here. So we know at x equals 0, it's actually 0, 15. 0, 15. So it's actually over here. So like that. Like this. And this goes straight. And this one just goes slopes down to this. Perfect. And yeah. And let's actually label all those endpoints. So it will be, 0, 15 here. This point here will be 15. Again, so 15, 1 through 5. This point here would be 20, 1 through 5. And this point would be, 27.5, 15. Perfect. Let's move on to the next question. Done. So question 3 states, consider the function g of x and state the value of the limit where it goes from negative to easy. So I can just do this. Let's just go on g of x. And let's actually, define it. So 2 to the power of x plus 5. So if I want to find the limit as x approaches negative infinity of g of x, we get 5. So that is just 5. The derivative of g dash of x can be expressed in the form of this. The real number k is what? Easy. So let's just find g of x. So your k value is just log e2. K log e2. Next one. Let a be a real number. Find in terms of a the equation of the tangent to g at point this. Okay, so we can go menu, just calculus, tangent line of g of x, comma x, comma at a, and we get this. So let's write that down. So y equals 2a log e 2 x minus a log e 2 minus 1 2a plus 5. Done. Hence, or otherwise, find the equation of the tangent that passes through the point origin corrected to its best. So easy. So we just let y equals 0 and x equals 0. So this would be 0 to a log e2 0 minus a log e2 minus 1 to a plus 5. So your your a values, so your a values are going to be what? So if I take this, let x equals 0, I want to solve answer also this equals 0, comma a, and we, what have I done here? Okay, so I got this, and I'll let x equal 0, done. And I also want this to be equal to 0, and we want a comma a, okay. An argument must be an expression. Why is it doing that? So, okay, what have I done? So take this, if I sub in 0, here, it will cancel all this out. We'll be left with that. And we want to let that equal 0. And so we want to solve this answer. Comma a. Okay, now we get the value of a. So the value of a is this. So let's just write that down. So 2.6178. So your actual equation is y equals, go back to your equation, this, and sub that in. Control enter, and we get this. Okay, 4.254x. This is just 0. Negative 2 is like negative 2 times 10 to the power negative. Such a small number that's negligible in maths. So we only have this, and yeah, so this would be correct to 3 decimal places would be 4.2 5. Yeah, so to 3 decimal x. It'd just be 4.25x. That's right? 100% if that's right. I want to make sure. Hence, once find the equation to the tangent that passes through the origin. I just want to double check if I did everything wrong. So I took this, and I let it equal to 0, and let's say that x is also equal to 0. Now solve, answer, comma a, and we got this, and I sub. Okay, perfect. That's it. Yeah. Let's just highlight that. Done. Next question. So let h of x be this. Find the coordinates of the point of inflection for h. Easy. To find the point of inflection, so let's just define h of x. It's the double derivative, and let the double derivative actually equal 0. So negative x squared. So I can just say solve, and solve actually h of x. Okay, let me just go on here. Double derivative h of x should equal 0, comma x, and control enter. This to 2 decimal places, so this would be 2.06, comma, and what's h of this value over here? It is to 2000 negative 0.07. That's it. Find the largest interval of x values for which h is strictly decreasing. Okay, so h is strictly decreasing. So if I write h of x, draw h of x, okay. It's only strictly decreasing from this value over here to this. So from the maximum to the minimum. So let's just find those values, the t values, and yeah, from this value to this value, and they're going to be included. So, because it's strictly decreasing. So what I'm going to do is go on menu. Well, what are we trying to find first one? The maximum. Okay, go to calculus, maximum, h of x, so h of x, comma x, where x can be between negative 2, 1. Whoa, no, so negative 1, got a comma here. To that, so control enter, and it's this value over here. And the next one is just the min from 2 to 4. So 2 to 4. And we get this. So it's from this to that. Okay. Let's write those down. The interval x is an element from to 2 decimal places, 0.1 49 to 3.21. Done. Apply Newton's method with an initial estimate of x0, 0 to find approximate x-intercepts for h. Write the estimates of x1, x2, x3 in the table correct to 3 decimal place. Okay, not too bad. So what I'm going to do is do this. I know h of x, luckily. So what I'm going to do is I'm going to say just g of x. No, actually, f of x. Because the f of x has no actual function. So if I can say f of x, and I can make f of x as like a generator for values for Newton. So x minus, I know the function is h of x, the derivative of h of x. Perfect. So for the first one, I want x1. So what I'm just going to do is I'm going to write f of the first value, which is 0, x0. And remember, I just want, if there's one f, it means the x1 we're trying to find. Control enter, it gives you this value. So to 3 decimal points, that's negative 1.44. The next one, if we want x2, what we're going to do is we're going to bring this again. Now we're going to have 2 f's. Control enter, we get this new value. So let's write that down. Negative 0. Actually, to 3 decimal. Yeah. So I didn't write the other one to. Yeah, it's supposed to be 3 here. 897. Yes. The next one is another f over here, and that's going to be negative 0.773. Done. For the function h, explain why a solution, so for the function h, explain why a solution to the equation of this should not be used as an initial estimate of x0 in Newton's method. Okay, so let me just find the solutions for this. So it's natural log of 2 times 2 to the power of x minus 2x equals 0. So I'm going to solve answer comma x. We get 0.485. Wait, aren't these just the values that we just got from the Yeah. These are our the maximum and the minimum values. So they're saying why can't we start x0, your initial Newton estimate? So of course it makes sense why. Imagine starting a tangent. So here tangent, it's a horizontal tangent, and this horizontal tangent never actually crosses the x-axis. The tangent never crosses the x-axis. So even this one over here, if you draw a tangent, it's going to be a horizontal tangent, and it's never going to cross these x-axis. So we're not going to actually get any iterations or actually other x values. So the way I would write this is the values, so the solutions are stationary points. So they are stationary points. So we know that the solutions are stationary points, and their tangents are a horizontal line. Yeah, are a horizontal line that does not cross the x-axis, Therefore, Therefore, no other iterations. So therefore, no other iterations, will be found. Something like that. So the solution of the station points and their tangent are horizontal, does not cross the x-axis, so no other iterations will be found. Yeah. H. There is a positive real number there is a positive real number n for which the function f of x this has a local minimum on the x-axis. Find this value of n. So, all right. So if I just have a sketch of this, and we say, okay, n is, okay. This one's when n is actually equal to 2, and when n is equal to 2, what can we see? It crosses the x-axis at n equals 2. What about if we, wait. If I just say n to the power of x minus x to the power of n. Okay, so when n's equal to 1, it always crosses the x-axis at x equals 1. If I press 2, n equals 2, it has to cross the x-axis at, n equals 2. 3, 1, 2, 3. Yes, it also crosses the x-axis. 8. What about 4? 1, 2, 3, 4. Yes, it also crosses. So yeah, so the 5 is the actual. It has to cross on the it has to cross. So the value of n is where where one of the x-intercepts are located. So, all right. So what can we say? There is a positive real number n for which f of x this has a local minimum on the x-axis. Okay, so if it's at the x-axis, your x value, so for f of x, so your x value will be n. Yes, as we can see. So we can say that when f of n, or actually just, because here it's saying that there's a positive real number for which the function f of x has a local minimum. So it crosses the actual x-axis. That's good. With a local minimum on the x-axis. So if it's on the x-axis, so x equals n, we can say that therefore f dash, the derivative at that n value, should actually equal 0 because it's a local minimum. Is that right? Let's check if we can find it. So we want to be careful of that. I'm just going to make a new problem because I don't want to mix those up. Okay, so again, I want to define f of x as n to the power of x minus x to the power of n. All right, so I know that we're saying the derivative of f of x at x equals n. So this solve answer should equal 0, comma n. So n is equal to 2.7123. It just says find the value of n, not in decimal places. Wait, isn't it just e? If I put e, 2.71. Why does it not give me e then? Why did it have to give me that? So n equals e. N is just equal to e, yeah. So when x equals n, f dash of n equals 0. So yeah. Should that give me 2 marks? So I know the answer, but is that enough? I'm just going to write this. So log e of n minus 1, n to the power of n should actually equal 0. That's it, yeah. And I want to double check if it's right. If I put e. Aha, perfect. Yes, it's a minimum. Let's go to the next question. Question 4. A manufacturer produces tennis ball. The diameter of the tennis ball is normally distributed with a random variable d, which has a mean of this and a standard deviation is. Find the probability that this. Okay, easy. I love the basics of probability. So it starts off basic. So we can go menu, probability distributions, normal CDF. So from 6.8 to infinity, our mean is 6.7 and our standard deviation is 0.1. Okay, and we get this beautiful value. So let's write that down to for decimal places. So that will be 0.1587. Next question. Find the minimum diameter of a tennis ball that is larger than 90% of all tennis balls produced. So if I'm going to just draw a normal distribution and say this is your diameter. So find the minimum diameter of a tennis ball that is larger than 90% of this. So this here is 90%, yeah? We're saying it's 90%. So find the minimum diameter of a tennis ball that is larger than 99% of all tennis balls. Yeah. So this ball over here, that one that we're trying to find, is larger than all this 90%. So that's easy. So we can just go on our calculator to find that and go on probability distributions inverse norm, and our area here is 0.9. Our mean is still 6.7 and our standard deviation is 0.1. And it gives you this. So that is your thing. So your diameter to 2 decimal places, that's 6.83 centimeters. Tennis balls are packed and sold in cylindrical containers. A tennis ball can fit through the opening at the top of the container if the diameter is smaller than this. So what we're saying is, if this is 6.95 and the smaller than this, it would fit pretty much. So find the probability that a randomly selected tennis ball can free through the opening of the top container. Easy. So yeah, we just want to find the probability that, for example, x is less or equal to 6.95, which is equal to what? I'm just going to use this and just say this one 6.95, and a second say this negative infinity. Yeah. Is that right? No, not that one actually. This one. 0.1. This one's supposed to be 6.95. This one's supposed to be 6.95. And this one's negative infinity. And we get this, so let's write that down. 4 decimal places, that's 0.9938. In a random selection of 4 tennis balls, find the probability that at least 3 balls can fit through the opening at the top of the container. So let's say that x is binomial, and there are 4 tennis balls, and the probability that they will actually fit through the container is what we just calculated, didn't we? That find probability can fit through the opening at the top. Oh yes, we just calculated it's 0.9938. So if I want the probability that at least x is greater or equal to 3 of these balls to fit, we can just use our calculator. Menu, go to probability distribution, go to binomial CDF. The number of trials is 4. Probability of success is 0.9938. Your lower bound is 3, and your highest bound is 4. Okay, and we get this. Is that right? So from, we said this, that, from 3 to 4. Perfect. So that. Let's write that down. So it's 0.99. Okay, wait. 98. Wow. So 0.9998. Okay. Yeah. Looks good. A tennis ball is classed as grade A if the diameter is between 6.54 and 6.86. Otherwise, it is classified as grade B. Given, so just that word given gives you conditional probability. Given that a tennis ball can fit through the opening at the top of the container, find the probability that it is classed grade A. So we want to find the probability that it is in class A. So A, given that the ball can through the opening on top of the container. So fit container. So it's just a probability of A intersection the fit container. So in other words, let's just make our life easier and say, what's the probability that it's grade A, we said. Find the probability that it is classified. So if it's classed A, it has to be from 6.54 less than x less than 6.86, given it can through the top of the container. And we said that if it fits through the top of the container, what is the probability? Find the probability that a randomly selected terminal can fit through the top of the container is this, where x is less or 6.95. X is this 6.95. So I need to find the intersection. So if I was drawing this, say 6.54 is here, 6.86 is here, 6.95, and this to that. The point of intersection, yes. So the point of intersection is just the probability that 6.54 less than x less than 6.86 all over the probability that x is less than 6.95. And that is what? Easy. So, using our calculator with normal CDF, we know to get from 6.54 and 6.54 and 6.86. Is that right? So 6.54, 6.86, 6.7, this and that. Good. That gives you this. And we've already calculated the probability that it's less than 95 is that. So we can say this divided by this. Is that right? Yes. Control enter and we get this value. So that's your answer. To 4 decimal places, that's 0.8960, yeah? 89, that's yeah. Perfect, 60. The manufacturer would like to improve processes to ensure that more than 99% of all tennis balls produced are classified as grade A. Assuming that the mean diameter of the tennis balls remains the same, find the required standard deviation of the diameter in centimeters, correct to 2 decimal places. So the mean is the same, but we wanted 99% of them to be grade A. And we know, okay, so what we're saying is, so if I just draw a diagram of here, if we want 99% of them to be between that, they have to be between 4A 6.54, 6.86, yeah? It has to be between those two. All right, and we don't know the standard deviation. So what I would do is the probability, so the probability here is this inside here, both of them. So here is what? 0. I know that 0.1 we divided by 2, it gives you 0.05. So this here is 0.05. I know that. So that here is 0. And if you had 0.05, the other one would be there. Am I not? Wait. I just want to make sure I'm doing it right. Am I making some mistake here? So, if that's 99%, then the other ones are 1%, which is 0.01, yes. And we divide that by 2. Yes, it is, okay, so no, I did make a mistake. So, it's actually 0.005. So, it's that. So, we can say the probability that x is less than 6.86 should equal that 99, so that 0.99 plus the 0.005, which would give us, if we use the standard normal difference, so that's z is less than 6.86 minus your mean, because the mean is the same, they said. Your mean is the same. So what was your mean? 6.7 over your standard deviation should equal this, which is 0.99, which is 0.995. Now that is easy to calculate. So go on menu, probability distributions, inverse normal. The area is 0.995, and that should equal this. So, and we equate that to 6.86 minus 6.7 over O. I'm going to solve, answer, comma, O. And we get this value of O. This is your standard deviation. So your standard deviation to 2 decimal places is 0.06. Done. An inspector takes a random sample of 32 tennis balls from a manufacturer and determines a confidence interval for the population proportion of grade A balls produced. The confidence interval is this, correct for all decimal places. Find the level of confidence interval that the population proportion of A balls is within the interval as percentage, correct to the nearest integer. So we're just trying to find if it's 95, okay, or that, yeah, what kind of percentage. So to do that, we just need to find the z value. So if I can just think about it. So if I just use one of these, for example, I know the formula is p hat minus z square root p hat 1 minus p hat over n. This here should equal this one over here, 0.7382. P hat is easy because P hat is just the addition of them and divided by 2. So if I can just do my calculator. So what's 0.7382 plus 0.9493 divided by 2. That gives you 27 over 32. So 27 over 32. So we can say 27 over 32 minus z is what we're trying to solve, over 27 over 32, 1 minus 27, so 1 minus 27 over 32, all over n, and that all should equal to 0.7382. So let's solve that calculator. Solve 27, 32 minus z times the square root of this. I'm just going to copy this. 27, 1 minus that over n should equal to this value over here. Control, and our n value is actually, 32 tennis balls. So Control Z, we get Z is equal to 1.64, which, if I'm not mistaken, 1.96 is 95. So 1.64 is approximately 90%, if I wasn't mistaken. So yeah, 90%. So 90%. 90%. Let's just actually make sure, double check that. So if we save with 90%, we can just say menu probability discussion nominal CDF. Let me actually copy that. I want to double check if that's true. So if I go probability distributions, so negative that, enter. Oh, what happened? Probability this, okay. Negative that, okay. Yes, 0.89 or approximately percent. So it's 90%. Yes, to the nearest integer is just 90%. That's that. Okay, let's just get that question done. A tennis coach uses both grade A and grade B balls. The serving speed in meters per second of a grade A tennis ball is a continuous random variable V with a probability density function this. Find the probability that the serving ball of grade A ball exceeds 50 meters per second. Correct to false. Okay, so we're just saying, because it's continuous variable, it's a probability density function. So yeah. So if you want the probability that it exceeds this, we're just saying from 50 to the max, which is 3 pi squared, plus 30 of f of v dv should equal what? So let's first define f of v. So f of v is 1 over 6 pi times sine v minus 30 over 3. So the integral from 50 to 3 pi squared plus 30 f of v dx is what? Oh, no, not dx, dv. Control enter and it gives you this over here. So that's 0.25 decimal, that's 0.1345. Is that right? Find the probability that the serving speed of a goal exceeds this. Okay, perfect. Find the exact mean serving speed for grade A balls. Easy. So your mean is just, it's just 1 mark. I'm just going to do it over here. So if I know that, if I can just change this to a 30, so from 30 to 3 pi squared plus 30, and I'm just multiply v here. And we get this, and it says that find the exact, not the decimal, so it's just your expected value of v is 3 pi squared plus 4. Next question. The serving speed of grade B balls is given by the continuous random variable w with the probability density function of GW. The transformation transforms the graph of f to the graph of g, where this is that. Okay, this question is similar to the 2021 actual exam, this question. So if the mean serving speed for grade B balls is this, find the values of A and B. Okay, so what I would say here is first, have a look at f of x. So if I draw f of x, let's say, I don't know, it's fake graph. So we know that the mean of f of x as well. We calculate it to be, 3 pi squared plus 12. Yes. And what's happened is that there is some dilations, and there's a dilation by factor of b parallel to the x-axis, and the other one a dilation by factor of a parallel to the y-axis. So then what happens is, and it transforms the mean to here. Now the only thing that would transform it is that b, because that b value is a dilation by factor dilation by factor of b parallel to the x-axis, so it affects these x values. So what I would think is, so what's happening is, what I would do to find that value of b is, this is our original, and it's been multiplied by b to get this. So we can say, what value of b is multiplying by this to actually get us to this. Let's just, use our calculator. So b times 3 pi squared plus 12 should equal 2 pi squared plus 8. And we want to solve answer b. We get b equals 2 over 3. So your b value is 2 on 3. Okay, we got our b value. Now we have that b value. This could actually be very useful because we know that this is restricted from 30 to 3 pi squared plus 30. So if we multiply, all those values by b, we actually get these restricted ones here. We get those restricted ones. So let's do that. So, oops. Okay. So let me just do that. So what's 30 times 2 over 3? It's 20. So here's 20. And what's 3 pi, so let me just get this here, plus 30, times 2 over 3. And it gives us this value over here. So let's write that down. 2 pi squared plus 20. Now the area from 20 to 2 pi squared plus 20 should equal 1. So what we can say is the integral of, we can take the a, because what we're going to calculate is a, of f of w over b. Well, we know b is 2 on 3. dw should, or dv should actually equal 1 from 20 to 2 pi squared plus 20. That's what we're going to calculate. So a times this from 20 to this value over here, where f is, we can just write it as, v 2 over 3, v should equal 1, solve, answer, comma a. So a is actually equal to 3 on 2. So those are your values. I hope those are right, because this question is similar to the exam from 2021. So a is equal to 3 on 2. B is actually equal to 2 on 3. Those are your values. If that means something smart, find the values of a and b. Perfect. This is the last question. Please tell me yes. Well, it's been long. Let's go quickly with this. Let f of x be this and g of x be that. Complete a possible sequence of transformation to transforms f to g. Dilation by a factor of half. Yes. There is also a reflection along the y-axis. So reflection along the y-axis. And if we solve this inside, 2 minus x equals 0, so 2 equals x. So there's also a translation of 4 units. 2 units. To the right. That's that. Two functions g of 1 and g of 2 are created, both with the same rule as g, so g, but with distinct domains, such that the g of 1 is strictly increasing and g of 2 is strictly decreasing. Give the domain and range for the inverse. So let me just actually, to do those, let me just, define them, because I have no idea what that, how they look and stuff. So f of x is e to the x plus e to the negative x, and g of x is just g of x is 0.5 f of 2 minus x. That, and we will graph them. Yeah, so two functions g of 1 and g of 2 are created, both with the same rule, okay, but with distinct domains, such that g of 1 is strictly increasing and g of 2 is strictly decreasing. So if I just graph g of x, okay, so g of 1 is strictly increasing. It's the one from 2 to infinity. So if I can write that down, so okay, it makes sense. Okay, because I was just, so the g of 1 domain, dom, is just 1, 2, so it's from 2 to infinity, and the range of g of 1 is from 1 to infinity. And g of 2, we just need g of 1, don't we? Yeah, we just give the domain and the range of the inverse. Well, easy. The inverse of g of 1 is, the domain of it is just the range, 1 to infinity. And the inverse of the range is just the domain of g, which is 2 to infinity. Done. That's not too bad. All right. I want to make sure, yeah, so we've done that. So g of 1 is strictly increasing, yes. And yes, so the domain and the range of g inverse. So the inverse is that. Okay, perfect. Shown below is the graph of g and the inverse g of 1 and g of 2. Yes. Okay. The intersection point between the graph of y equals x, y equals g of x, yes, and the inverse of g of 1 and g of 2 are labeled as p and q. Okay, so p is here, and q is here. Find the coordinates of p and q, correct 2 decimal places. Okay, well, p and q, it's the g of x. You know how we know g of x? Isn't it just the point of intersection with the line y equals x? So yeah, can we just say g of x equal, yeah, just let's say g of x equals, so g of x equals x. Let me solve, answer, comma x, control enter. So the coordinates of p and q, because it, the point of intersection is y equals x, so they both have the x and y coordinates the same. So to 2 decimal places is what? So we can say that p is 1.27, 1.27, q 4.09, 4.09. Done. Find the area of the region enclosed by the graph of g, the inverse of g, and the inverse of g2. Okay, so that, and that. So we're trying to find this area right over here. Luckily, it's easy because it's symmetrical. So if I can find, because y equals x is the top function and g of x is the bottom function, and we can find this area, we need to find those point. Oh, we already know the point of intersection, it's just p and q. And yeah, if we find those and double them, we should get that. So to do that, I'm going to do double from p, which is 1.27, 4.09. From that to that, where x minus g of x dx. Okay, yeah, should give us the answer to 2 decimal places. So we're saying the integral, twice the integral from this point over here, this point over here, x minus g of x dx should equal this. To two decimal places, that's 5.56. Yeah, units squared. Done. Next question. Let h of x be 1 over k, where fk minus x, where k is an element of 0 to infinity. The turning point... Wait, so h of x is 1 over k, fk minus x, where k is 0 to infinity. Okay. The turning point of h always lies on the graph of the function 2xn, where n is an integer. So n is an integer. Okay. Find the value of n. Okay, let's just do h of k. So what I'm going to do is, okay, h of k, h of x is what? It's just 1 over k times f of k minus x. Okay, so if I graph that, so we know, take this one over here out. So h of x, okay, we'll put it as a slider, yep. And we also know that 2x to the power of n lies there. These two here. Okay, so what it's saying is that the turning point of h, so this turning point, will always lie on the graph of this, this over here, where n is an integer. So if I just move k, for when k is greater than 0, it just moves like this. So it moves like this. And if... Okay, yes. If n is greater, it wouldn't... So, but if n is less... Look at this. This is perfect, actually. So if n is like the negatives, so if n is less, can you see how the graph would like start to intersect? So the turning point of h will always intersect. And if we go more, well, it doesn't intersect anymore. So, but we know n is an integer. So maybe a -4, -3, -2, -1. So at -1, okay. What about 1? Okay, still intersects. I have no idea. But, yeah, 2, 3, 4. So it's always I want to 100% double, is that an intersection? So intersection, yes, it is. And if I go to 20, let's say even 20, let's go further. It's always intersecting. Yes, so I didn't even have to do the algebra, actually. Just n equals -1. And it says to find the value. Yeah, n equals -1. That was good and easy. Let h of 1. Oh my god, so wait. Let h of 1 where k is greater than infinity. So h of 1 is h of x, so the same rule. The rule of the inverse of h of 1 is this. What is the smallest value of k such that the h will intersect with the inverse of h of 1? Give your answer correct to 2 decimal places. Oh my god, 1 mark. Okay, so what we're saying is, I want to delete some stuff here because it's too much. So if I take this out, and this over here is h of x, yes? Bring that back. This over here is h of x, and it can go to infinity, where k is greater than 0. If I draw the thing they're telling me here, which is the inverse of it, natural log of k over 2 times x plus 0.5 root x squared times x squared minus 4 plus k. Yes. Draw that, and it's this. Okay. And, okay, this is, we want them to, wait, what is the smallest value of k such that it will intersect the inverse of h? So, if we go more, okay, so it's already intersected. So it has to be around, what about from 0? Because k has to be from 0, from, let's say, 3. Okay, look. So as we bring k, we can see how it intersects here. we want that minimum, the smallest value of k, like where it just intersects once, and the more we do, it will intersect forever now. We just need to find that value over here. But we do know one thing, that when they, because they're inverses, we know that the point they will intersect should, like y equals x, yeah? This point, they should, intersect at that point. So knowing that, we can just say, okay, h dash, we know that, because we know the function h dash of x, we can say h of x, so h dash of x at should equal 1 when when it intersects, pretty much. Yeah, because the intersection is where it intersects the y equals line, this one. So we can say, well, be careful actually, because we've already defined k's and stuff, so we want to just take everything over here and just make a new problem. This, go up, this is here. Okay, geez, that's nothing. Okay, that's it. So we have these two, so, and we also want to get this one. No, we don't actually need that one. Yeah, so we know that if we solve where the gradient of h of x, actually just, yeah, when is the gradient of h of x? So when's the gradient of h of x equal 1? And we want to solve, we solve answer, comma, x. And we get this, ooh. So we probably need two stuff. Okay, so we know that this is true. We also know that it intersects at, the h of x equals, the line h of x intersects the line, y equals x. So we can just go on menu, go on, not calculus, just go on menu, go on calculus, maybe? Nah, algebra. Solve some equations. We're going to find k and x, but we want k actually. So the first thing we know is this. We also know that h of x should equal to x. Aha! We get two values. Yet what? K is negatives. K is negative here. Why is that? Let's write that down. It says that k is negative. So what's that value? This value. Let's just double check what this value is. Ah, okay. So, because it's like a reflected image, for example, this over here is negative 1.27, which, yes, that line intersects with it. And if I, can you see how they would, well, if I just take this and say negative 2 here. So if you like, here, negative 1.27 is over here. That's where they intersect, yeah? Over here. It's actually just, if we bring it over here, it's the same point. It's the same point as the x. So here is x equals blah, blah, blah. What was it? Negative 1 point. It will just be the positive, and also the k value here will also be the positive k value. And we need to double check it. Is that true? Can we take this and make it positive? Aha, perfect. Yes, it does work. So it is this k value. And that is the smallest, and we know that also it is a positive. So yeah, k is just 1 mark, so 1.27. I mean, you could have also graphed it pretty much. I mean, very much guess it, because we knew that it had to be around this. So, just from that, I know it's around 1. I would have done this also, 1 to 2. So then, okay, around here. So it's around 1 to 1.3. I would have just started putting values, okay, as you can see, and I would just zoom in. Because it's only to 2 decimal places and it doesn't need any working out. So you can just, okay, if I zoom in a little bit more, close to that, around here. Perfect. And I would just double check by going to intersection. Yes, they do intersect at that point. So yeah, that's how I would do that question. Last question, please. On what? Wait. What's happening here? No, is it just... Oh, no, it's just twice. No, it's... Yeah, it's accidentally done it twice. Okay, yeah, it's the last question. I thought it was the, oh my god. It is possible for the graph of h and the inverse of h1 to intersect twice. So it is possible. This occurs when x equals 5. Is that true? Let's put that equals 5. Oh, let's zoom out. Have a look at that. Yes, it does. Find the area of the region bounded by the graph of h, so this, and the inverse, so this, when k is equal to 5. Easy. I'm just going to get rid of this. I don't need this. Okay, very easy. Because now we have a value of k. Doesn't that make my life easier? So I just need to find this intersection here, point of this intersection here, and just, this is the top function. I don't need this actually. Yeah, the top function, which is in this case this minus h of x. So if I write k here, yes, k is 5 now. That's perfect. So we can just say we want to solve where h of x is just equal to find the point of intersections. Where is it? This one. Right over here. That, comma, x. Control enter. We get these two values, so that's good. So we can just say, let's write the integral. So it'll be the integral from this over here to this over here. What is the top function? So the actual, this one over here. Just want to copy this. This one minus h of x. H of x, yes. So dx, enter, control enter. So yes, your answer is that. So what I'm going to do is, because it's 2 marks, I'm going to just say, solve h of x equals h inverse of x. So the integral is going to be 1.45 to 8.78, where h inverse of x minus h of x dx should equal to decimal places 43.91 units squared. I'm not sure that's 100% true. Let me double check it. So if I go over here, analyze graph, bounded area from this point to this point, yes, 43.9. Yes, that's great. Oh my god, this is tiring. Okay, guys, thank you guys for watching. I hope you learned something from this video. I mean, that's rubbish, this thing over here. Just, yeah. Thank you guys for watching. Make sure to please like and subscribe for more videos. I'll be hopefully making more videos in these holidays. And yeah, good luck with your other exams, guys. I believe tomorrow for special students, your specialist exam is coming. It's tomorrow. Good luck with those who are doing that. And yeah, have a good day, guys. Bye-bye.